Arc length still A. Total circumference is still 2 pi r. Central angle measure is still theta, but the angle of one rotation is now 360 degrees. Right? That you can simplify, but it doesn't get as simple as the one up above. This formula you don't necessarily need as long as you can convert angles to radians. If you change this around now, right, and put this up on top over here, what is it going to simplify to? I'll write it that way. I'll write A equals theta over 360, but then we have times 2 pi over here. Can you simplify anything on that? You don't need the degrees there, right? That's just comparison, because the degrees are going to cancel out from that. You could simplify it a little bit. You could divide by that if you want to, and get 180 here. So you got pi times r times theta on the top over 180. This is a formula you could use if you have an angle in degrees. Or you can just change any angles to radians and just understand this first formula here. Okay? I don't want you to necessarily approach this by saying, I have to remember this formula and memorize it and then just blindly use the formula without thinking. This only applies when the angle is in radians, right? So this is pretty important over here. Where is it, the angle in radians? If you look at a couple of the things down below here, I'll show you these are not hard questions. It's just asking for a distance around the outside. This is one of these things that once you've been shown, oh, there's a formula for it, I think you think, oh, I got to memorize that formula, and if I don't know the formula, I can't answer the question. As long as you know what 5 radians is, and it probably helps to draw some kind of a picture of the thing here. 5 radians is somewhere over here. Right, there's 5 radians. And we have 10 centimeters here. So the question is, how far around is it from there all the way to there? It's 50, right? Absolutely, it's 50. Because that's the definition of what that is. If you have 5 radians, you got 10, 10, 10, 10, and 10, right? You have 10 all the way around the outside. If you want to use a formula, you can, right? R times theta, and just fill this in and say I have 10 centimeters times 5. There's actually no units on radians. We talk about radians being a unit of measure of angle. It's not really a unit. It's just a ratio of two distances. We can talk more about that in a second. If you use I'm going to blindly use the formula without thinking method, you're likely to get this one wrong, because you could draw the same kind of circle here, roughly the same, and then say I have an angle of 25 degrees now, which isn't very big. It's over there somewhere, right? And somebody says I have 10 centimeters. If you're blindly using the formula, you might be tempted to say, oh, look, it's r times theta. I memorized that formula. I got 10 centimeters times 25, so 250 centimeters. Does that look like it makes any sense? There's no way this short little distance could be 250 centimeters, right? This formula does not apply if the angle's in degrees. So your choices are either memorize the other one as well and understand the difference, or I would just suggest that you know how to convert angles, and then you can do this. If you take theta in degrees, if you want to convert degrees to radians, we have looked at this. If you want to convert degrees to radians, you can just multiply by pi over 180, right? If you have 70 degrees, that's the same as 70 pi over 180 radians. You could just make it a fraction pi over 180, because pi over 180, that's the same. That's like multiplying by 1. Like in chemistry or physics or whatever, if you multiply by 1 kilometer over 1,000 meters, are you actually changing the number that you started with? You're not, right? Because that number is 1. Multiplying by pi over 180 is not changing it. Pi radians over 180 degrees. If you want to go back the other way, not that we need that here, but if you do want to go back the other way, you just multiply by the reciprocal of that, 180 over pi. Whatever way you change angles. So you could use this formula and just say, I have to times by pi over 180 here before I do it. So it's the same as 10 centimeters times 25 pi over 180. And then it'll work out to something that makes sense. I'm sure you can come up with a number there for yourself. Are we okay with this? I'll leave that other question for you to do sometime. You've worked with formulas before. If you're approaching this from the formula, like I said, rearrange the formula here. This is not how, you don't have to do it. I'd be just as happy, if not more happy, if you did it from just understanding the concept of what a radian is, right? If you draw a picture and say, well, if I have 3 centimeters around the outside and the radius is 10, how many radians is that? You could almost answer that without even writing anything down. But I'll leave that for you to think about after. You okay? We've probably spent more time than we should on that first section, but it's important to get a real sound understanding of what radian measure is before moving on. We're going to look at angles and standard position next.